we now discuss the solution of the problem from the section Trigonometry, and the problem is on the inverse trigonometric functions. This question has appeared in Joint Entrance Examination Main held on 24th June 2022 in the first session. The problem is the set of all values of k for which tan inverse x whole cube plus cot inverse x whole cube is equal to k times pi cube, where x belongs to the set of real numbers, is the interval. We are given 4 options. In each option, the intervals are here. So the 4 intervals are given here. The set of all values of k for which this is true is the interval that is one of the following 4 intervals. Let's now discuss the solution of this problem in detail. That is the given question to us. Solution: tan inverse x whole cube plus cot inverse x whole cube. We use this formula: a cube plus b cube is equal to a plus b whole cube minus 3ab multiplied by a plus b. We use this and write tan inverse x whole cube plus cot inverse x whole cube is equal to tan inverse x plus cot inverse x whole cube minus 3 times tan inverse x into cot inverse x multiplied by tan inverse x plus cot inverse x. So that's what we have written. So we used this formula, written this as this one. And we have tan inverse x plus cot inverse x is equal to pi by 2 when x belongs to R. So we have this one. So wherever there is tan inverse x plus cot inverse x, write down pi by 2 and we get pi by 2 whole cube minus 3 into tan inverse x into cot inverse x. For cot inverse x, we write from this cot inverse x is equal to pi by 2 minus tan inverse x. So for cot inverse x, we have written this one into tan inverse x plus cot inverse x is pi by 2. Pi by 2. So that will be equal to pi cube by 8 minus 3 times pi by 2 into tan inverse x into pi by 2 minus tan inverse x. Now send this tan inverse x inside. Then you will get pi cube by 8 plus 3 pi by 2 into tan minus tan inverse x into minus tan inverse x is plus tan inverse x whole square. Minus tan inverse x into pi by 2 is minus pi by 2 into tan inverse x. Now this is looking like a square minus 2ab. Now add plus b square, make it a perfect square, and subtract b square. That means make it a perfect square by adjusting the terms. That will be equal to pi cube by 8 plus 3 pi by 2, and this is made perfect square, tan inverse x minus pi by 4 whole square. We have added pi by 4 whole square, that is pi square by 16, therefore subtract it, minus pi square by 16. Now the terms are adjusted. Now what we do is 3 pi by 2 multiplied by minus pi square by 16, and that will be equal to minus 3 pi cube by 32 plus 3 pi by 2 into tan inverse x minus pi by 4 whole square. That means this term we have taken out and written outside. Now when you simplify pi cube by 8 minus 3 times pi cube by 32, you will get pi cube by 32 plus 3 pi by 2 into tan inverse x minus pi by 4 whole square. So the given tan inverse x whole cube plus cot inverse x whole cube is equal to pi cube by 32 plus 3 times pi by 2 into tan inverse x minus pi by 4 square. That is the simplification. And that is what we have in the last slide. Now we see tan inverse x belongs to what? When x belongs to R, tan inverse x will belong to minus pi by 2 to pi by 2. Correct. Now tan inverse x minus pi by 4 will belong to minus pi by 4, pi by 2, minus pi by 4, comma, pi by 2 minus pi by 4. So minus pi by 2 minus pi by 4 is minus 3 pi by 4. And pi by 2 minus pi by 4 is pi by 4. So tan inverse x minus pi by 4 will belong to this open interval. And when you square it, it will be 0 to pi by 4. When you square it, 0 square pi square by 16. It will go up to that. And this end 0 to minus 3 pi by 2. When square it, it will go to 0 to 9 pi square by 16. 9 pi square by 16. Between these pi square by 16, 9 pi square by 16, the greater one is 9 pi square by 16. Therefore, the square of it, tan inverse x minus pi by 4 whole square, will belong to the interval 0 to 9 pi square by 16 and closed at the 0 end. So, is a half closed interval. Half closed interval. So, that is this belongs to this one. Now, why are we doing? Because we want to evaluate this, where this value will belong to. And now multiply 3 pi by 2. So tan in 3 pi by 2 multiplied by tan inverse x minus pi by 4 whole square will belong to, multiply 3 pi by 2 inside, 0 into 3 pi by 2 is 0, 3 pi by 2 into 9 pi square by 16 is 27 pi cube by 32. So it belongs to this interval. Now add pi cube by 32. So you will get this one. So pi cube by 32 plus 3 pi by 2 into tan inverse x minus pi by 4 whole square will belong to 0 plus pi cube by 32, comma 27 pi cube by 32 plus pi cube by 32. When simplified, you will get pi cube by 32, comma 28 pi cube by 32. Cancel the common factor for both numerator and denominator and take out pi cube common outside. Then it will be interval 1 by 32 comma 7 by 8 into pi cube, and it is closed at 1 by 32 n. Agreed? Agreed. So this will belong to this will belong to this one. So this part, the right hand side part belongs to this. Therefore, the left hand side also belongs to this. So tan inverse x whole cube plus cot inverse x whole cube is equal to this one, and that belongs to this. That belongs to this. But so the tan inverse x whole cube plus cot inverse x whole cube will belong to this interval multiplied by pi cube. It is given to us in the question, tan inverse x whole cube plus cot inverse x whole cube is equal to k times pi cube. Therefore, from the above result, k must belong to this interval. So the values of k for which this is true will belong to this interval. Therefore, k belongs to 1 by 32 comma 7 by 8 closed at 1 by 32 n. Let's look at our options. K belongs to this interval. This interval appears against option A. Therefore, our answer is option A. And that is the solution of the problem from the section trigonometry. And the question is on inverse trigonometric functions. I am sure that you have understood the solution of this problem. And I wish you all the best. Thank you.